Consider this code that defines a print name method. This method accepts two parameters, name and greeting. Then it displays a customized personal greeting to the person using a console.writeLine method. The greeting parameter is optional, which means that the calling code doesn't need to supply a value for that parameter. Now, in order to make the parameter optional, you just have to supply a default value, which here I'm setting equal to the string hello. And so this is the syntax. Just the regular parameter declaration as usual, adding an equal sign, actually an assignment operator, and setting it equal to whatever value. Here it's a string. If this was defined as an integer, it needed to be an integer. Some other object need to be some other object. So still strongly typed, but I'm setting the default value of greeting. All right, and then I have this flexible parameters method. And as you can see, I'm declaring a string called person and assigning it the value Don Kiley. And then I'm calling print name 4 different ways. And these different ways demonstrate both named and optional parameters. Okay, so the first one here is pretty much a typical way to call a method. This is the traditional way. You supply a value for all the parameters. For the name parameter, it's passing the value of person. I'm passing it by value, so it's getting a copy of this string. And then the second parameter I'm passing as a string literal. Nothing magical about those selections. I just wanted to show that this works both with values of variables as well as literal values. All right, and then it also passes the parameters in the order in which they're defined in the method. Names first and then greeting, and so that's what I'm passing to that method call. So nothing really all that interesting here. Same thing we've been doing throughout this course so far. Now with this second form of the print name method here, things get a little bit more interesting. This takes advantage of greeting as an optional parameter. Because the calling code here is fine with the default greeting of hello, it doesn't bother passing the second parameter at all. Okay, and so this works perfectly well. Calls the method, greeting gets the value hello, and it displays the greeting. All right, then here's another variation, and this is using a named parameter. So this again takes advantage of the optional greeting parameter by omitting that value. All I'm passing is the name parameter. But this time it explicitly uses a named parameter by specifying the name of the parameter followed by a colon. And then by the value that I want to pass in, which in this case is the value of the person variable. I could have made this a literal string if I wanted to. All right, and so both of these methods do the same thing. In both cases, the value of the person variable is being assigned to the name variable in the method, and this is going to display hello greeting because I'm using the default parameter value. All right, and then this last form of calling print name shows the benefit of using named parameters. For whatever reason, I want to pass greeting first and then name. In this case, I have to use named parameters because I'm not supplying the information, the parameter values, in the order in which they're defined within the method. So in this case, I have to specify that this first value that I'm passing is the greeting parameter, so that's going to be assigned to the second parameter there. And the second the argument actually that I'm passing in then becomes the value of the name parameter. That is the first parameter in the method definition list. All right, so this provides all of the information that the method, the called method, needs in order to get the right value to the right parameter. All right, I'll go ahead and press F5 to run this. And G for named and optional. And here you can see the results. So once again, this is using salutations Don Kiley. I'm passing in both values. Here, these two, I'm letting it use the default value of greeting. One, I'm not using a named parameter. Here I am using a named parameter. And for both I get hello Don Kiley. And then here's where I'm just passing them in reverse order. I'm specifying a non-default value for greeting. And so it displays "Greetings, Don Kiley." Now, the combination of named and optional parameters really become useful with methods that have multiple parameters, several or all of which are optional. With the combination of these features, you can specify just the arguments that you need to pass to the method in any order, as long as any that you don't provide values for are defined as optional with a default value provided using this syntax right here. So for example, if I had now a third parameter, just call x, I'm not being very creative right now, I could just have comma x equals 5, or int x equals 5. And then, in that case, I would have 3 parameters, only one of which is required, and 2 are optional. And I can continue to add parameters as long as I want. Now, when using optional parameters, you have to place them in the method declaration list after all the required parameters. So the order in which I placed them here was not an accident. This optional parameter has to be after all required parameters. So if I have 5 required parameters, I have a comma delimited list declaring them, and then I have 1 or more optional parameters. Now, I'm not going to talk about parameter arrays, which is another way of passing information to a method. But just tuck away in the back of your mind that if you have a parameter array, the parameter array needs to be passed after all optional parameters. So the order is required parameters, optional parameters, and then a parameter array. C# compiles the default values of optional parameters into the metadata of a calling assembly. The implications of this are that if you change the default value in the method definition, you could break code that's passing the old default value to your method. But this is only going to be a problem if the calling code is in a different assembly than the method definition. So that's not going to be a problem here. These are all part of the same class, and it's all compiled into the same assembly, so there's not going to be a disconnect like that here. But if this was in a different assembly, you change the default greeting, then it could affect the calling code there. And then, when using named parameters, C# will ensure that the code evaluates arguments in the order they're specified by the arguments to the method in the calling code. So my example here was there. I passed in 2 parameters in reverse order to how they're defined within the method. So in this method call, this fourth call to the method, C# evaluates greeting prior to name. So it's going to read the method, it's going to see this, it's going to evaluate that parameter, see that it's a literal string greetings, and pass that to the greeting parameter. And then it's going to evaluate what's over here. This is a variable expression. It's going to read that value, make a copy of it because I'm passing it by value, and then assign it to that parameter. Now, this example deals with constant values. So I have a literal string and a value of a variable. So the order of evaluation doesn't matter in this particular case. But the evaluation order would be important if the arguments were method calls. So if in fact, instead of passing a literal string there, I instead called a method, invoked a method, passed in any other parameters, that other method executes, and then returns a value, and then that's what's assigned to greeting. And then for the second parameter here, I call another method, that a completely different method or the same method. This is called second. So the order in which those methods are evaluated is left to right. If there are any interactions between those two methods, some side effects, then the order in which the methods are invoked could matter. So you have to be aware of the order in which named parameter values, the arguments, are being evaluated. So there's some little bit of complexities with this, but it's really handy. And there's a lot of time where named parameters are very handy, particularly if you have a number of optional parameters. Instead of supplying all of the optional parameters and just putting in default values or null or whatever might be appropriate, you can just pick and choose which optional parameters you want to specify. Here's a little bit of a funky, but oftentimes very helpful feature in C#. And they're caller information attributes. So caller information attributes let you provide information to a method about the code that is calling that method. These take the form of attributes that decorate method parameters. That's kind of a new thing that we haven't encountered before. We haven't worked with attributes all that much, and parameter attributes are really just kind of weird. Cool, but very weird. So the way it works is that it makes it easy to get the path of the source code, the line number, and the method name of the calling code. So within this method that's being called, you can get information about the calling code. In some scenarios, this can be very useful information, particularly logging scenarios. So here's a sample method that I'm going to use to demonstrate caller information attributes. All it does is just calls a method called log call information and passes a single parameter, which is a string. So this overall method itself is pretty unremarkable. It doesn't return anything. It doesn't take any parameters. But this is the code that I'm going to call from my console. All right, but the idea here is that I'm logging some information, and presumably I'm passing in some sort of important, pertinent information about what's happening in the code. And then here's the definition of that log call info. I have 4 parameters, which is kind of weird because I only have one parameter that I'm passing in here. And of course, that's because they're optional parameters. But what's really weird is that all 3 of the optional parameters are decorated with different attributes. And that's how it's typically referred to. This attribute, and I know this is an attribute because it's in square brackets, is decorating each of those parameters. All right, so I have color file path attribute. And so the full name of the attribute there, as you can see there, is color file path attribute. Throughout the .NET framework, that's a convention. You name attributes something, maybe something attribute. But then you don't have to use the attribute syntax here when you actually use the attribute. So be aware of that. But the actual name of the class in the .NET framework is color file path attribute. And what this attribute does is when this code executes, it supplies to the parameter that it is decorating the full path of the source code file that contains the calling code. So again, that's this code right here. Now, in the simple example, this is all a single code file. But this could be in a different assembly from this code, and so this is going to return the file path of the code of the assembly where this code is located, because this is a calling code for that method. All right, and as you can see, it's a string value. And then the caller line number provides the line number in the source code where the method that contains the caller information is called from. So presumably this is going to show 187. Because again, it's recording this line that called into this method from the calling code. Okay, and that returns an integer, and I'm initializing it to the default 0. And then the final attribute is caller member name. And this provides the method or property name of the caller, which here is going to be the caller information method. That's a string, and I'm initializing it to an empty string. All right, so these attributes of the method parameters cause the decorated parameters to return the relevant information. And then I can use the values there within this method. And here I'm just using a simple console.write line to say called from member name, so that's the name of the method, the line number in the file. Okay, so in the simple application, I'm just displaying it to the console window. In a real application, I'd probably be writing this to a log file in a database or an XML file someplace or some persistent storage where I can store log information. Okay, and as I mentioned, you do have to provide default values, which is a little bit weird. I could maybe initialize them in here, but if I go ahead and get rid of that default value, notice that I have red squigglies, never a good sign, and down below it says the caller line number attribute may only be applied to parameters with default values. Okay, so the compiler at compile time, not at runtime, the compiler at compile time is enforcing that requirement. So I have to have default values for any parameters that I apply those attributes to. Okay, and then the last thing to point out is if I go to the top of the code file here, all of those attributes are part of the system.runtime.compiler_services namespace. So it's part of the .NET framework, of course. But in order to not use the fully qualified name system.runtime.compiler_services, if I come back down here, I didn't preface all of those attributes with that fully qualified name. I have to include a using statement. And so I included that in the code. All right, so let's see what we end up with. I'll go ahead and run the application. Press H for caller information. And there you can see that that method was called from caller information. So that was the method that called that method. Line number 187, my prediction held true. And here is the fully qualified file name for the code file in which this appeared. And then finally, I display the message that I'm passing to the log call info that's here part of message. No requirement, you don't have to provide a message parameter like that, but it's nice to include some sort of custom information about what's going on within your code.